Evaluating limits using trigonometry. Beautiful. So to evaluate limits using trigonometry, all you have to do now is, so this says evaluate the limit as x approaches 0 of sine x over the root of x. All you're gonna have to do is this sine x over root x, you want to get it in the form sine x over x. So look what we're gonna do. What we're going to do is we're gonna multiply this by root x over root x. So we're gonna rewrite this as a limit of root x times the sine of x, and then we're gonna divide it by root x times root x. So all we did here is multiply both sides by root x over root x. By multiplying both sides by root x over root x, the root x times the root x in the denominator just becomes x. So this is going to become the limit as x approaches 0 of, this is now root x times sine x over x. Root x times sine x over x. Now, of course, we know that we can break this up as the product of two limits. So we can then use the limit laws to break this up as the limit as x approaches 0 of root x multiplied by the limit as x approaches 0 of sine x over x. So that's why we had to multiply both sides by root x over root x. And so we'll multiply this by that. So this is what we get now. But when you plug in x as 0, you're going to get 0 here multiplied by, you plug in 0 for here, sine x over x, when x approaches 0 is 1, but 0 times 0 is 0. Nice. And so here's it now, just to get verification, the limit of sine x over, there we go, 0. Easy, soft, nice. So we know we get 0. Let's look at another example. This question says, evaluate the limit as x approaches 0 of sine x over 3x. So we need to get it in the form sine x over x. So all we're going to do is, this 3 right here, we're going to factor out 1 over 3. This 3 right here, we need to remove this 3 right here. To remove that 3, we're going to just rewrite this as the limit as x approaches 0 of, to get this 3, we'll factor out the 3. So it's 1 over 3 times sine x over x. I didn't do anything wrong. Look, they're being multiplied. If I put in back the 3, you get back your 3x. So now you can factor out 1 over 3 put in front of the limit sign to write 1 over 3 times the limit as x approaches 0 of sine x over x. But the limit of sine x over x is, you said it, it's 1. This part is 1. But it's going to become 1 over 3 multiplied by 1. So the limit of sine x over 3x is 1 over 3. Easy, soft, nice. That is 1 over 3. Just for verification, it's always nice when you get verification. Sine x over 3x, 1 over 3. There we go, 1 over 3. Beautiful, nice. Let's look at another example here. Now this one look diabolic. It says evaluate the limit as x approaches 0 of sec 2x minus cosec sec 2x plus tan x over x. To do such a question, all we're going to have to do is, in this case, I notice there's a sec x here and a sec x here. So look how I'm going to do it. You may see it a different way. I see it a different way. It doesn't matter. I'm going to separate this as two fractions. The fraction that's coming to my mind, as I said, what is coming to my mind, you don't have to see it how I see it. You may see something else, but what I see is to break this up as sec 2x minus cosine x sec 2x, and then I break up this part as plus tan x. I might say, but I don't do nothing yet. Just wait. I'm going to separate it as this part over x plus this part over x. That's what is coming to my mind. I separate it like that. Now, since I separate it like that, what next is coming to my mind? Well, what I am thinking of doing now is break it up as the limit of two things now. So this is going to be the limit as x approaches 0 for this side, plus the limit as x approaches 0 of tan x over x. But we know that the limit of tan x over x is 1. So that part here, Gucci already. The part here, nice. The part here, straight. Because now this is going to be tan x over x. So all we need to do is work out this side. But on this side, what do I notice? I observe that I can factor out a sec 2x over here. Then I'm left back with 1 minus cos x. And this is all being divided by x. Yeah, man. So now what I'm going to end up do is I'm going to rewrite this part now as the limit as x approaches 0 of, I'm going to write it now as a limit as x approaches 0 of sec 2x times, I'm using limit laws now, times the limit as x approaches 0 times the limit as x approaches 0 of 1 minus cos x, 1 minus cos x over x. But we know that the limit of 1 minus cos x over x is 0, plus the limit as x approaches 0 of tan x over x is 1. So now that part is just plus 1. Now remember, the limit as x approaches 0 of 1 minus cos x over x is 0. And so it doesn't even matter what the limit, when you plug in 0 in sec x, it doesn't even matter because 1 minus cos x over x is 0. That works out to be 0 plus 1, and that is because this part is 0. By limit laws, that part is 0. So this works out to be 0 plus 1, which is 1. Nice and easy, soft. Now, of course, I strongly recommend you check your answer if you're not confident. So we're just going to type it in. This was what? Sec 2x minus cos x sec x. This says theta, but it should have been x right here. Divided the limit as x approaches 0 of sine 6x over 3x. So we need a 6x. To get a 6x, we're going to have to multiply the numerator and the denominator by 2. So it's going to become the limit as x approaches 0 of sine 6x. This is sine 6x over multiply the denominator by 2 and the numerator by 2. So put a 2 right in the numerator and put a 2 down in the denominator. 2 times 3x. So then what this works out to be is the limit as x approaches 2. This works out to be the limit as x approaches 2 of 2 times the sine of 6x, 2 times the sine of 6x over 2 times 3x is 6x. And so then we plug in the 0 now, plugging in the 0, that will work out to be plugging in 0. Sine 6x over 6x, this is 1. So this answer will work out to be 2 times 1. And 2 times 1, we know that is 2. So this works out to be 2. Nice. It's always good when we check our answer. So sine 6x over 3x. Let us do it. Sine 6x divided by 3x. We do that, we get our 2. Easy. So